Section 5.1, Modeling Data with Quadratic Functions. We're going to talk about first the standard form of a quadratic function. So you have f of x is equal to ax squared plus bx plus c. And of course, remember, f of x is just the fancy notation that we use. Instead of using y equals, we can use f of x equals. So f of x stands for y. Now for this, the ax squared is your quadratic term. The bx is the linear term. And the c is your constant term. And remember that terms are separated by addition and subtraction signs when you have everything combined already and simplified. And the quadratic term is this one right here because you have x to the power 2, which makes it quadratic, to the first power makes it linear, and when you have x to the 0 power, which means it's really just 1 when it's not there, it's your constant term. Now in this case, when you have your standard form for a quadratic equation, I know that my a value cannot be equal to 0 because if a was equal to 0, then the function is the form of, if I plug 0 in here for a, 0 times anything is 0, and notice this term right here would be gone, and you'd be left with y equals bx plus c, and if you look at this term right here, you know that your quadratic term is now gone, so this would be then a linear function. And if a was 0 and b was 0, so 0 here and 0 here, you would have f of x is equal to c, or you could write y is equal to c. And when you have y equals some number, this is just a constant function. And remember, when y equals some number, you actually have a horizontal line on your graph. Now, the next thing we need to be able to do is determine if a function is a linear or a quadratic. Identify the linear, quadratic, and constant terms. When you're doing this, the first thing you have to do is put it in standard form. So you need to simplify and combine like terms, or write in standard form, I guess. Simplify and put in standard form. So for this first one, we have a binomial times a binomial. Remember, things are simplified when you don't have parentheses and all your terms are combined. So I need to FOIL this out. So my first terms, my outside terms, inside terms, and last terms. And notice that I have the, this should have been negative 8x. So negative 8x and 3x are like terms, so I get 2x squared minus 5x minus 12. Now this is my quadratic term, this is a linear term, and this is constant, so it's in standard form. Everything's combined, so I know that this is a quadratic function. Now I need to identify my quadratic, linear, and constant term. So my quadratic term is this term right here, so I write down 2x squared. The linear term is negative 5x, and my constant term is negative 12. So what I would do right now is I would push pause and see if you can do B and C on your own, and then unpause it, and I'll work it out. So for B, notice that this right here doesn't have a number on the outside, so I don't have to distribute anything, and there's no power, so I don't have to multiply or FOIL anything out. So that means I can just go ahead and drop the parentheses. So when I do that, I have x squared plus 5x minus x squared. Now with this, I know that x squared and negative x squared are like terms. Those cancel each other out, and you're left with just 5x. So if you look at this term right here is linear because x is to the first power. So this is a linear function because I don't have a quadratic term. So there is no quadratic term. My linear term is 5x, and I have no constant term as well. Now if you look at C, remember when you're solving these equations, you have to distribute this number that's in front first. So I have 3x squared minus 6x, and then here you're distributing negative 3 to both those terms, so don't forget the minus there. So minus 3x squared, and minus becomes plus 6. So I have these two are like terms. So 3x squared minus 3x squared cancels itself out. And then you have negative 6x plus 6, and those are not like terms, so it stays negative 6x plus 6. And for this one, I know this is in standard form. This right here, term is linear. This is constant. There is no quadratic term. So since there's no quadratic term, this is a linear function. And I know that the linear term is negative 6x and the constant term is 6. Now let's say I didn't have a linear term, then it would just be called a constant function. So that's the first part. Now the next thing we're going to talk about is the graph of a quadratic function. Remember when we talked about graphs of absolute values, we said that an absolute value makes a V-shape for your graph. Well, quadratic functions, the graph is going to be a U-shaped graph. So it's a U-shaped graph, or I could say a U-shaped curve. And it's called a parabola. So parabola is the fancy name for the U-shape that it makes. Now we have our parent graphs, which is how our shapes are going to move from these two different graphs. So for this first graph right here, this is y equals x squared, and this one right here, when it's opening downwards, is y equals negative x squared. So these two are the smallest shapes that we have for our quadratic functions, so they're the parent functions. Now there's a lot of different things that we can talk about this graph. So when I'm looking at this graph, I know that this point right here is called the vertex. So that's the vertex. And the coordinates for the vertex here are 0, 0. And if you look at this vertex, you'll notice that it is the very lowest point in your graph, and every other part of the curve is above it. So since this point is the lowest point compared to the other points around it, I know that this is a minimum value. So the vertex is a minimum. So it's a minimum value, and the minimum value is the lowest y value that you have. So in this case, the minimum value would be 0. So some other cool things about this graph. If I were to look at this graph and notice that if I were to cut the graph in half on the vertex, that if I folded the graph on this line, each side would match up with the other side. So this point, if I folded my graph, would match up with this point. So those are called corresponding points. This point right here would match up with this point. This point would match up with this point. And you could do that infinite many amount of times by matching one side with the other side when you fold it in half. So again, those are called corresponding points. Now, if you look at these two graphs in comparison, how do I know if my graph's going to open up, and how do I know if my graph's going to open down? Well, notice that this value in front of your x squared or your quadratic term is 1, and this one's negative 1. So you know that, and I'm going to write this off to the side, when your a value, so we have y equals ax squared, so when your a value is greater than 0, your graph is going to open up. And when your a value is less than 0, your graph opens down. So those are two different things that you can tell to help you tell which way your graph is going to open. And then also for this, another thing we're going to talk about is called the axis of symmetry. So I'm going to just move this up here. So the axis of symmetry is the line that divides a parabola into two parts that are mirror images. And this is the vertical line that is defined by the x-coordinate of the vertex. And I always abbreviate this so I don't have to write axis of symmetry out each time. A of S stands for axis of symmetry if you see me write that. The vertex, which we talked about, is the point at which the parabola intersects the axis of symmetry, and the y value of the vertex of the parabola represents the maximum, so maximum or minimum value of the function. So let's look at this graph over here. We said this was a minimum value. So right here, I know the minimum value is 0 because that's the y-coordinate of my vertex. And the axis of symmetry, which is a line of symmetry, because remember your parabola is going to keep on going up towards infinity. That's why those arrows are there. So we say that the axis of symmetry in this case would be, so I'm going to write A of S for axis of symmetry is the line x equals the x-coordinate of your vertex, which is 0. And notice that I wrote x equals 0. It's a line, so you need that, because remember, vertical lines, you use x. If it's a horizontal line, you use y equals, but this is vertical. Now, if I look at this next graph, y equals negative x squared, right here, the same thing. I can fold my graph on this line right here, and if I fold my graph on that line, notice that each of these points on either side of the line would be corresponding points, because if you fold the graph in half, they match up with the other point on the other side. So for this, I know that the vertex of the graph is 0, 0. I know that instead of being a minimum value, now it's the highest point on my graph. So every point around this point is below it. So we have a maximum value. So the maximum value is, in this case, the y value of your vertex, which is 0. And I know that the axis of symmetry is the x-coordinate of the vertex, which is going to be x equals 0. So these are the things that I should know when I'm looking at the graph of a quadratic function. So remember, the name for the graph is quadratic, and the shape of the graph is called a parabola, so don't get those confused. Now let's go to the back side of your sheet. So on the back side it says find the vertex, the axis of symmetry, maximum or minimum value, and then we want to find the points that correspond to P and Q on the graph. So let's do A together, and then I want you guys to pause it and do B on your own, and then check your answer. So for A, we want to find the vertex, and I always do that first because that tells me a lot about my graph. It helps me with my axis of symmetry and the max or min value. My vertex is right here, so I went over 1 and down 1. So my vertex is at negative 1, or negative 1, positive 1, negative 1. Now that I have my vertex, I can figure out my axis of symmetry. So the axis of symmetry is always the x-coordinate of your vertex, which is 1, so I have to write x equals 1. So that would be this line on my graph right here. So that would be the axis of symmetry. So when I fold my graph on that line, each point on the other side corresponds to the other side. And this vertex is the lowest point of my graph. Everything is above it, so it's a minimum value. So the minimum value is negative 1 because it's the y value. So the lowest value I can have on this graph for y would be negative 1. Now, from this, I can find the corresponding points. So before I can find the corresponding points, I have to first figure out what is point P on my graph. So P, you go over negative 1 and up 1, 2, 3. So negative 1, comma, 3. And Q is at, we're going over 1, 2, and up 0. Now for the corresponding points, we always label those P prime and Q prime so we can differentiate between the two. So now if I look at P first, remember the corresponding point would be when you fold your parabola in half, it matches up on the other side. So this is why I always draw on the axis of symmetry, because then I can just count. This is 1, 2 away from my axis of symmetry on this side, so 1, 2 away on this side would be this point right here corresponds. So this would be P prime. So that point is at 1, 2, 3, 1, 2, 3. So 3, comma 3. Now if I do Q prime, so Q is right here, so the point that corresponds to it would have to be on the other side of the axis of symmetry, so it's 1 away here, so it would be 1 away right here. And that O just stands for the origin, but I'm going to turn it into a Q and make it a Q prime so that we know that's where Q prime is. So Q prime is at actually 0, comma 0, the origin. So pause it, see if you can do the same thing for B, and then unpause it and check your answer. So if we look at B, I know I have my vertex. The vertex is right here, which is at negative 1, 2. Then I have the axis of symmetry. Always is the x-coordinate of your vertex, which is negative 1, so x equals negative 1, which means that if I draw in my axis of symmetry, that would be right here. So when I fold my graph in half on that line, it matches up to the other side of the parabola. My vertex here is the highest point on the graph compared to the points around it, so that's a maximum. So the maximum value is 2 because that's the y-coordinate of my vertex. So the maximum value is 2. Now I need to figure out what P and Q are on my graph. So P is the point negative 1, 2, and comma 1. And Q is at 1, negative 2. So if I want to find the corresponding points, I have to look at the other side of the parabola, what would match up. So P prime would be right here, because this is 1 away from my axis of symmetry, and so is this side, so this would be P prime. So that's at 0, 1. And then Q prime, since Q is right here, this is 1, 2 away from my graph, and so 1, 2 away would be right here. So if I fold my graph in half, this would be the matching or corresponding point. So that's at negative 3, negative 2. So those are all the points from my graph. Now, the very last thing that we need to do is we need to find quadratic models given a bunch of data points. We've already learned to use linear functions to model data. Some data can be modeled with a quadratic function. So we're going to do that for this, and then we're going to find y when x is equal to 7. Now, you can do these quadratic examples by hand, which I'll show you in class, but we're going to just go ahead and use our calculator for this. So when you're doing quadratic models, remember that when we were doing linear models and we had a whole bunch of data as more than 2 points, we used our calculator and we plugged it into our stat plot. So we're going to do the same thing. So this is all written right here for you if you don't remember, but get out your calculator and make sure you're doing this with me as I go. So I'm going to zoom out a little bit so you guys can see more of the calculator. So the first thing I want to do is I want to put this in my stat plot. So I go to my stat button, which is right here, and hit stat, and then hit enter on edit. And then list 1, remember, are your x values, so 2, 3, and 4. So 2, enter, 3, enter, 4, enter. Remember, if you have something in your here, you could always just hit clear and push down, and that clears it out. And remember to make sure you're working in list 1 and list 2. If you accidentally deleted it for some reason, you'll have to come to me in class and I'll fix it for you. So then list 2 goes your y values. We have 3, 13, and 29. Now that I have everything in my calculator, I'm going to go ahead and come up with the equation. So to come up with the equation, I'm going to go to stat, right arrow over to calculate, and remember before we did linear equations, so this was the linear button number 4, but now we're doing quadratic regression, so we want to hit number 5. So I'm going to hit 5, and then if I hit enter, I get my quadratic equation, y equals ax squared plus bx plus c. My a value is 3, b is 5, c is 1, And we'll talk about this r squared value later, but let's go ahead and write down these values. So I got y equals ax squared plus bx plus c. So my a value is 3, my b value is -5, and c is equal to 1. So with those values, I can write my equation, y is equal to 3x squared minus 5x plus 1. Now with this equation, since my a value is 3, I know that my graph is opening upwards. So remember we talked about that on the other side. So this is my a value, it's positive, so greater than 0 opens up. If it would have been negative, it would be opening down. It didn't ask me for that, but I'm just letting you guys know. So for this, now I want to figure out, I want to find y when x equals 7. So if I want to find y when x is equal to 7, that means I'm just plugging x into my equation. So y equals 3 times 7 squared minus 5 times 7 plus 1. So all I have to do is plug this into my calculator, and then I figure out that y is equal to 113. Now remember, we can also use function notation when I'm doing this. So if I use function notation, which we're going to start using more, that would be f of x is equal to 3x squared minus 5x plus 1. So since my x value I want to find is 7, that means I would plug 7 in for x, like this. And notice it's the same thing as what I did just a minute ago. It's just that we have f of 7 equals this. So then you get f of 7, oops, is equal to 113. So remember that says the same thing. This just means when x is 7, y is, or f of 7, which means your y, is 113. So it's just a fancy way of writing it. Also remember, in my calculator, I can put this into my y equals without having to type it. So if you wanted to, you could just type it in and then go to your table and look. Or remember that when we're doing our stat, we could do a stat calculate, and then number 5. If you go to your vars, which stands for variables, we're doing something in our y variables, and it's a function, so number 1, and we want to put it into y1. Enter. So notice when I go to my y equals, that should put the equation in for me. I don't know why it rounded, so it must just be some kind of error with my calculator, so I could probably just type it in by hand, but I should get the same answer when I go to my table. So I want to look at a value of 7, and notice I do. I get 113. So for some reason the calculator just had this weird rounding when it put it in there. So it's the same thing. Or if I wanted to, I could just type it in by hand. So 3x squared minus 5x plus 1. It comes in handy when you plug that in, because when you get values that are very long for equations and you have a lot of high numbers that you have to plug in, it makes it a lot easier to use that and look at the table. So what I want you to do is do the next example on your own, which says the table below shows the height of a column of water as it drains from a container. Model the data with a quadratic function. Graph the data and the function. Use the model to predict the water level at 35 seconds. So this time right here is your time elapsed, and the water level would be after the time elapsed. So this is your x values and these are your y values. So list 1 and list 2, and then use that to predict the water level at 35 seconds. So just to show you, you can graph it on your calculator. You don't have to worry about graphing it by hand. So if I wanted to graph this in my calculator, remember second y equals, you need to make sure your stat plot's turned on. So I'd hit enter and turn it on. Make sure you're list 1 and 2, which I am. If you hit zoom and go all the way down to 9, it says stat. So if I hit enter, notice that gives me my points. And then since I put my equation in there, that's why that line is there. But had I not put that equation there, I would just get those dots. So that's what you're going to be doing for your homework. So make sure that you have that with you for class, that last problem on there.